Dear students, in this lecture we will discuss about Fourier series for the different interval c less than equal to x less than is equal to c plus 2l. We know that Fourier series of fz, we know that the Fourier series of fz for the interval d less than equal to z less than equal to d plus 2 pi is defined as fz is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nz plus summation n equal to 1 to infinity bn sin nz. Suppose this is the equation number 1, where a0, an and bn are the Euler coefficients, and formula of a0 is 1 upon pi d2 d plus 2 pi f of z dz. An is equal to 1 upon pi d2 d plus 2 pi fz cos nz dz, and bn is equal to 1 upon pi d2 d plus 2 pi fz sin nz dz. Okay, and suppose these are the set of equations 2. Okay, here we are using variable z in place of x for converting the Fourier series for this interval in suitable form. That's why we took here z in place of x. Okay, as we know that in many engineering problems it is required to expand a function in a Fourier series over an interval of length 2l instead of 2 pi. The transformation from the function of period 2 pi to those of period 2l is quite simple. This can be achieved by a transformation of the variable. Okay, and means this can be achieved by taking one substitution z is equal to pi x upon l. Okay, z equal to pi x upon l means dz equal to pi upon l dx. Now we change the limit. Here lower limit lower limit is z is equal to d. When z equal to d, it is d equal to pi x upon L, that is LD upon pi, this is equal to x. Okay. And what about upper limit? Upper limit, when z equal to d plus 2 pi, then from here z equal to pi x upon L, that is d plus 2 pi is equal to pi x upon L. On solving this, that is LD upon pi plus 2L is equal to x. Okay. What is the lower limit? Lower limit is equal to x equal to LD upon pi, and taking this as a c. Here LD equal to pi is c. And what is upper limit? Upper limit x is equal to LD upon pi plus 2L. Here we are assuming LD upon pi equal to c, that is c plus 2L. Okay. Now from equation 1. Now from 1, what we have? Here f is equal to z. Z means here z equal to pi x upon L. Pi x upon L is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nz, means cos z equal to pi x upon L, that is n pi x upon L plus summation n equal to 1 to infinity bn sin n pi x upon L. Okay. And a0 is equal to 1 upon pi. Limit of the integration is c to c plus 2L. When we take this substitution, z equal to pi x upon L, it is c to c plus 2L, and this is f pi x upon L. And dz, what is dz? Dz is pi upon L dx, that is pi upon L dx. On solving, this pi is cancel out. 1 upon L c to c plus 2L, and in place of pi x upon L, okay, suppose this is f pi x upon L dx. Okay. Now what is the formula for an? An equal to 1 upon pi c to c plus 2L f pi x upon L, and cos nz. Cos nz means cos n pi x upon L, and dz means pi upon L dx, that is this pi is cancel out. 1 upon L c to c plus 2L f pi upon x L, and this is cos n pi x upon L and dx, n pi x upon L and dx. Now what is Bn? Bn is 1 upon pi C2C plus 2L f of fz, means here we put z equal to pi x upon L from 1 and 2. Here from 1 and 2. This is pi x upon L, and here we have sine n pi x upon L dx, that is, and what is dx? Dx is, here what we have, dx is equal to dz equal to pi upon L dx, that is pi upon L dx. These two are cancel out, means we have Bn is equal to 1 upon L C2C plus 2L f of pi x upon L, and this is sine n pi x upon L and dx. That is, on solving this, here we are taking here f pi x upon L is a function of x. Here we are replacing this by f of x. Okay, this is a function of x. We can also write in this form. What we have from all these equations, here fx equal to this, here we have fx, fx, fx. Now we have formula fx is equal to, that is, fx is equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon L plus summation n equal to 1 to infinity bn sin n pi x upon L. Okay, where formula of a0 is, here a0 equal to 1 upon L C2C plus 2L f of x dx. Okay, here we are replacing this f pi x upon L is equal to function of f of x, and an is equal to 1 upon L C2C plus 2L fx cos n pi x upon L dx, and bn is equal to 1 upon L C2C plus 2L f of x sin n pi x upon L dx. Okay, now when c equal to 0, here a0 will be 0 to 2L, 0 to 2L, 0 to 2L, and if c equal to minus L, if we have c equal to minus L, in that case a0 will be 1 upon L minus L to plus L f of x dx, an equal to 1 upon L minus L to plus L f of x cos n pi x upon L dx, and bn is equal to 1 upon L minus L2 plus L f of x sin n pi x upon L dx. Okay. Now two cases arises. When fx is an odd function, when fx is an odd function, that is f of minus x equal to minus fx. Now what would case first, when fx is an odd function, that is f of minus x equal to minus fx. In that case, fx is an odd function, then by the property of definite integration, this integral will be 0, because it is limit is minus L2 plus L, and if it is an odd function, then a0 will be 0. What about an? If fx is an odd function, cos n pi x upon L is an even function, and product of n odd function and n even function will be an odd function, means this complete function will be an odd function. By the property of definite integral, this will be 0, n equal to 0. And what about bn? If fx is an odd function and sin n pi x upon L is also an odd function, this is an odd function, this is also an odd function, and product of two odd function will be an even function, means this complete function will be an even function, and by the property of definite integration, this will be equal to 2 times 0 to L f of x into sin n pi x upon L dx. Okay, now we come to the second case. When fx is an even function, when fx is an even function, means f minus x is equal to plus fx. Okay. Now what will be the value of a0? When fx is an even function, means here we get a term by the property of definite integration, this will be 2 times 0 to L, that is 1 upon 2 upon L 0 to L f of x dx an. Here fx is an even function, sin fx is an even function, cos n pi x upon L is also an even function, product of two even function will be an even function, means this complete function is an even function, and by the property of definite integration, this is equal to 2 upon L 0 to L f of x cos n pi x upon L dx. Next we will discuss bn. Here fx is an odd function and sin n pi x upon L is also an odd function. Fx is an even function and sin n pi x upon L is an odd function. Product of n even function and n odd function will be an odd function, means this complete function will be an odd function, and by the property of definite integration, this will be 0. Okay. In case number 1, in case first, we have this Fourier series fx is equal to, in this, when fx is an odd function, we get only one term in the Fourier series. Here a0 will be 0, an will be 0, and here we get only this term n equal to 1 to infinity bn sine n pi x upon L. When fx is an odd function, we get only sine terms in the series, and when fx is an even function, in that case bn will be 0. We get only cosine term in the series, that is, here we get a0 by 2 plus summation n equal to 1 to infinity an cos n pi x upon L, and bn will be 0. Okay, in this way we can find out Fourier series for the different interval c less than equal to x less than equal to c plus 2l. In our next lecture, I would like to take some example on this interval c less than equal to x less than is equal to c plus 2l. Okay, thank you very much. I think all you have understand the different intervals c less than equal to x less than equal to 2l. If you have any queries regarding this 7th lecture on Fourier series, then you can comment on comment box, and if you feel this lecture is helpful for you, then please like and subscribe this channel. Okay, thank you very much. Have a nice day, and Bharat Mata ki Jai.